All right, so let's look at Desi, our Desmos friend. And so yesterday we were looking at this, right? We're like, what happens when I change the K? Oh, folks, I forgot to say, does anyone have earbuds in, or does anyone have a telephone that is going to distract them? And if that is the case, please put it away. Okay. Yeah, thank you. So here's my K. Fun. Okay, but we want more. We want more. You know what we're going to do? We are going to add something. Whoa. Anyone have a guess which well, you can see it. What's the variable? Sorry. What's the letter that we're using for this transformation called? Anyone know what I've added? Still moving up and down, but we're changing something. Watch me. We're changing whoop, loop, 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 and we're also going whoop, whoop. So which letter is it? Which one did I click? A. Okay, so we know so far that A does this. It goes like this, and when it's not happy, it goes like this. If it's like this, do I have a maximum or a minimum? Right, it's going down, down, down. This is as low as it goes, and then it goes up. If I'm like this, what is it, max or min? Everyone? Good, great. Now, have you talked about the other effects of the A? No. Okay, so let's isolate it. I'm going to stop you. I'm going to put you back to 0. And so what I'm doing, so we see that that the parabola is flipping, opening up, opening down. So the direction of opening is changing, but the other piece that's changing is the shape. And do you remember when we were working with the circle? When we added an A value that was in front of the bracket, that's when the shape of the circle started changing. When I put numbers in the bracket, the circle shape didn't change. It was just like moving. But now, when you put something in front of a bracket, and I want to show you where A is. Do you see the location of A? It's in front, touching the bracket, right? The K is being added on later. So what we're noticing is when we have a transformation or a number that's in front of the bracket, touching the bracket, it will affect the shape. Okay, now, you can't see the numbers. I want you to use your math intuition, your math guess. We're going to try to figure out, first we're going to guess which one of them makes the parabola like stretch. Okay, we call this a stretch. It's like imagine someone's holding my hands and they're pulling me up. So I'm being stretched. Versus if they put their hands and push me down, I'm being compressed. So stretched and compressed. So we've got two numbers to work with. If I have what, yeah.
I'm just a little confused what like the A and K values.
Thank you. So the question is, what do the A and K values represent? So essentially, we're adding numbers to an equation, right? So if I take this one off, and remember we had the circle, and I was just like, what if I add some numbers inside the bracket, in front of the bracket, on the other side? And we're like, oh, it's going to move, it's going to translate, it's going to transform, it's going to stretch. But then what we're noticing is there's like a pattern to them. There's a characteristic. So anytime you put a number inside the bracket, we end up getting a translation. Right? Yesterday for the parabola, we had a vertical translation, right? So we're like, oh, there's a connection inside the bracket. It's not just a random number. It's causing a translation. And this unit, we're looking at how to transform the parabola, how to take the parent parabola and transform it so it looks differently. Okay? Now, what we're noticing with the A is that when you put a number out front, I'm going to play, even if it's a circle, we're noticing that the number in front of the bracket is not translating it, right? Look at the center of the circle. The center of the circle doesn't change. It's still at the origin. So it's not translating, but it is changing the shape. And I'm going to add words like stretching and compressing. So that circle is being compressed and stretched, compressed and stretched. Does that answer your question? Thank you so much for asking. I'll give you 4.5 points for that. And so let's bring it back to the good old parabola. And we're seeing, okay, my parabola. Oh, I need to have a basic. Okay, so there I've got the parent. The red one is the parent parabola. So if I stop my A there. It's not stopping. Okay. Okay. So the red one is the parent parabola. My y equals x squared. Okay, solid. This is where I'm grounded, my foundation. Now I've got a parabola that is narrow, right? So do we call that being stretched? Is it stretched or compressed? Okay, right. You're stretching me. Okay. So here's the question. Do you think the A is a big number or a little number? Do you think the A is a negative or a positive? Okay, let's just guess. Reminder, the more you guess, the more your brain is active and ready to absorb and learn. So this is a good thing. Even if you make a mistake, it doesn't matter. Okay, so first of all, is it positive or negative? So is the A negative is the A value for the blue positive or negative? Show me. Everyone. You can go like this or you could go like this. Yeah, it's positive because it's opening up, right? Okay. Now, is it going to be bigger than 1? Or is it going to be a big number or a little number? Take a guess. Okay, thank you everyone for guessing. Now let's see what it is. At this point, X is 7.9. Sorry, A is 7.9. I'm going to put 100. Whoa. Okay, what number should I try now? 2? Okay. Okay, what number is going to make, what value for A is going to make the blue go on top of the red? Anyone know? You got it. Because 1 means there's no stretch, there's no compression. So if a number is bigger than 1, it is being stretched. What is a number that is smaller than 1? What is it? But no, give me a number. What number is going to compress this parabola? Talk with the person next to you. Give me an example of a number that's going to compress this parabola. All right, time. Give me, I heard something here. Okay, give me another one. Negative what? Negative 3? Okay, I got 2 answers. I got 0.5 and negative 3. Other thoughts? Just say it out loud. 1/3. Okay, let me give each of you 10 points for having the guts to say something. All right, I'm going to start with the smallest, negative 3. Folks, is this, so it is a reflection, right? It has reflected, gone upside down But here's the question. Is it narrower or wider than the red? It is narrower. And if you want, I can make this negative so you can see. Oh, so the -3, when A is -3, is it stretched or compressed? Stretched. So how do I get a compression? Let's try this one. So if my red is my parent function, look at the blue. It's just slightly being pushed down. Yeah. You got it. So let's look at that. So this is 0.5. Now I heard 1/3. Is 1/3 going to be more or less compressed? A bit more. Okay, how do I get it even more compressed? 1 over what? 8. Come on, let's make it exciting. 2,000. Dang. Woo! Oh, craziness. Whoa, that is a really, we got to zoom out. That is a compressed parabola. All right. Give me a negative compression. Like I want it reflected and compressed. What's my A going to be? Oh, wait, talk to your person. Give me a value so that parabola is reflected and compressed. All right, Ivy, what is it? Sure. -1/. Oh, excellent. Yeah, great. Okay, so we've seen we've experienced here what the A is going to do. So let's make a little note about our friend, the A value. All right, so what page are we turning to? You don't know? Okay, I'll figure it out in a second. We are going to the page that is called Quattro. 4. Chotere. 4. 4. All right, so we've discovered K. Woohoo! Now we've discovered A. Woohoo! All right, we're going to look first at A. We're going to make a note first for A when it's just positive. So let's examine these graphs, right? First of all, Gabriel, help me out. Why do we not like these graphs? Oh my gosh, how embarrassing. Let's go ahead and add some arrows, right? Miss Sly. Come on. It's like you're saying those parabolas stop. Oh, silliness. Okay. So let's look first at this box here. Y equals 2x squared. What is the A value here? A equals 2. Where is the vertex? Okay, look at it. Where's the vertex? Oh, okay, talk with your seat partner. What do you notice about the vertex of these 3 parabolas? And go ahead and write down that vertex for all 3 of them. They're all at the origin. Now, I want you to continue chatting with your seat partner to discuss why is it, why, I just asked you to stop. Oh, you're figuring that out. Okay. Why is it that they all have the same vertex? What happened or didn't happen? Discuss. Why do they all have the same vertex? Yeah, and what do you call it, Kate? No, remember it's similar to transportation. You got it. What? Yeah. All right, folks, my group here did great. Caleb, help us out. There's no K. There's no, what do we call K? Translation, what kind? Is it vertical or horizontal? Vertical. There's no vertical translation. Now, is there a horizontal translation? Did it move side to side? No. So because there are no translations, all the vertices are the same. That makes sense. And so the only thing that's happening is the shape changes. So when we have A equals 2, we have a stretch. When we have A equals 1/2, what do we call it? Compressed or compression, either one. And when I have A equals 1, this is called, what do we call this function? Thank you, the parent function, the basic one with no changes. Please. Sorry, I'm a dinosaur. My ears are horrible. Let me try this again. I thought I could hear it. Yeah. Yeah. Oh my goodness. Pushing the lesson forward. -5 points. That's wonderful. All right. So let me repeat the question. So the question was, so if you want to give it a y-intercept or change the y-intercept, she said, you can just give it a k value. But how do we move it side to side? I want to cry. That was amazing. I'm not going to tell you right now, but you'll find out by the end of the lesson. And you got -5 points. So that's pretty good. All right. I know. First person. That is amazing. All right. We've talked about the vertex. What is the axis of symmetry for all these parabolas? Say it out loud. Yeah. Well, don't just say 0. Yeah, x equals 0. Because if you just say 0, we might think it's y equals 0. Oh, no. I'm not going to describe the relationship because we kind of did that. But what we're going to do is we're going to add some info here. So this is just when A is positive. The vertex of all these graphs is at the origin. And folks, make sure you're adding the proper brackets. And the equation of the axis of symmetry is also always x equals 0. When A is positive, these graphs open, what is it, up or down? Gorgeous. Sorry, let me ask everyone. I didn't realize I was just asking Zeta. When A is positive, these graphs open. Yes! Okay. And the parabola has a, do you know what goes in there? I heard someone kind of try. What kind of value is it? Is it max or min? Minimum. Yeah, that was a bit trickier. Now, let's add that when A is greater to something, we get a stretch. And when A is less than something, we get a compression. And what is that something? This is only for positive values. Uno, right? 1 is sort of it's the parent value. Okay, but we got this, right? This is like, come on, let's add the negatives. We're ready. So bring in the negatives. What happens when we have a negative value? So we saw this as well. So for y equals x squared, A equals what? Uno. Okay, it's our parent function. Look at my short form for function, f with a shin at the end. I just like short forms. Do you know that this n with an underline as a exponent actually stands for ION? Yeah, it's like a shorthand. And where is the vertex? 0, 0, nothing changed. And the axis of symmetry also didn't change because we have no translations. Now, there is a change here, right? The parabolas are upside down. Now, I want to tell you what we call this mathematically. So imagine there's a mirror right here. When that parabola flips upside down, we call this a reflection. And it's a reflection in the x-axis. It's like it took a monkey bar, the x-axis is a monkey bar, and it flipped over it. So these are called reflection on x-axis or over x-axis or in x-axis, okay? But it's a reflection on the x-axis, okay? And so when A equals -2, is it a stretch or compression? Still stretch. It opens down, right? What's the axis of symmetry? X equals 0, no translation, right? And then if I have y equals -x squared, it's just the parent function flipped over. I would like you to add a sketch of y equals -0.01 x squared. So that's like 1 over 100. So I know the vertex is going to be at 0, 0. And is it stretched or compressed? And I'm better than the notes, so I'm putting arrows. And I'm calling this compressed. Compressed. We good? Not too fast? So let's go straight into the summary of this because we just, like all of this, we've already discussed. So in conclusion, when A is negative, right? A is negative. If it says less than 0, we're saying, oh, it's negative. The vertex is still at 0, 0. The axis of symmetry is still x equals 0. When the A is positive, it opens up. And when A is oh, shoot, take that back. That's supposed to say, what is it supposed to say? Negative. When A is negative, the graphs open down. And the parabola has a max min, max. And we're going to call this, when A is less than 0, it's a reflection in the x-axis. Yeah. Should I draw a picture? I always forget what the max and, well, now I don't, but I would always forget. So A is less than 0. It's the vertex. This is a max because it's kind of like the max height. Is that helpful? Yeah. And then when it opens up and A is bigger than 0, like it's positive, right? This is positive. This is negative. Here I have a minimum because it's like, this is as low as it goes. How low can you go? Well, this is how low the parabola can go. Helpful? Great. Okay. Are we ready to answer Zara's question? It was a wonderful one. And any guesses? The question was, how do we get the parabola to move? Well, I'm not even going to say move. I'm going to say translate. To translate side to side, i.e. horizontally. How do I make that happen? You talk with your people. What's left?
Oh, you have everything else except.
Yeah. Yeah. Do you need to go too? Yeah, go ahead.
Oh, right.
All right. So, folks, what is it? How do I make my parabola translate horizontally? Take a wild guess. What is it? Yeah. The x is a very good wild guess. So what you're saying is if I change this x, uh-oh. See what happened? Wait, let me try it again. Let's try 0.5. No! How about 100? No! Okay, it's not the x. But that was an excellent guess, and I'll give you 1/3 point. Okay, what's another guess? Yeah. Let's see. So if I take the h, and I'm going to go -7. Okay. I forgot to do with the first one. So give me your parent parabola. And if I go -7, how do you think it's going to move? Okay, so everyone, some people are going this way, some people are going this way. Let's see. So if I go -10, where's it going to go? Show me with your hand. Okay. What if I do +4? Ha. Okay. What if I do +100? Off the charts. Bye-bye. Yeah. So, yeah. So this is what's really confusing. Why is it opposite? And I'm going to show you. So do you see how in this formula, so this is the vertex form. This is the general formula for translations. See, we've got our A, our H, our K. See, we're saying plus K, but we're not saying plus H. We're saying minus H. So in the formula, this minus is supposed to be there. It doesn't say, hey, this means our H is negative. It's saying this is your H, and there's a minus in front of it. Okay, so let's break that down, how that's going to affect our parabola moving left or right. Oh, I forgot to do that. That's fine. So let's move to part 3. Where we're discovering the value of H. And notice again, in this equation, it says x minus H. Okay, so that means if I have y equals x minus H, give me an H value. Maya, give me a random H value. 2. Okay, and so everyone take a guess. If H is 2, put your parent parabola. Where's the H equals 2 going to go? Okay, let's see. So what that means is I'm going y equals x minus 2. Is the H positive or negative? Look here. The H is positive. It's just that the formula has a minus, so it looks like it's negative. Right? So when it says x minus 2, it actually goes 2 to the right. Now, Anna, can you give me an H value that's going to move it left? Okay, so if H equals -8, okay, what does the equation look like? So I'm going to have y equals x minus -8 all squared. Do you see what I'm saying? What's happening here, folks? Talk with your person. Why is this going to make it go to the left? So what is the equation going to look like? It's going to say x what? What's going to be between the x and the 8? Why is it a plus? Yeah, these negatives are multiplying each other. It's negative times negative. Oh, it's going to be positive. So when you see a plus in your parabola, when you see x plus 8, that doesn't mean your h is positive. It actually means that your h is a negative one. And so as a result, we are moving 8 to the left because the h is negative. Yeah.
When it's like x minus 8 in brackets squared, would that also mean that that h is negative?
No. So it's like this situation, right?
Oh, sorry.
No, don't be sorry. That's great, right? So the question was when it's x minus 8, well, it's saying the minus is supposed to be there. So that would mean, oh, the 8 is just a positive, right? That's a bit of a mind bender, but a really helpful point. And let's see. So when I have this parabola moving, the vertex is at -4. What is the h value of this parabola? Is it 4 or -4? Watch the equation. Okay, the equation says x plus 4. And I'm like, well, I know that it has to be y equals x minus something. So it's minus 4. So what is the h? Oh, it's -4. When I have this equation that says x minus 3, I'm like, okay, well, that means it's x minus, I'm going to do the h in a different color. So in this case, what is my h value? Just 3. So it's a bit of a trick because of that minus that's there. Okay, let me try another one because I get this is tricky. What if I have y equals x plus 100? Okay, write that down and write it down in a way where you have the minus, right? So I want you to fill in the blank here. Okay, what goes there? What is your h? Okay, so everyone write it down and we'll check if we all got the same answer. Check if your answer looks like mine. Yeah? So what is h? Oh, it's so ugly. H is -100. But it looks like it's going to be positive, Miss Sly. I'm like, I know. I didn't make up this formula. So don't blame me. Okay. Now, what I have, yes.
Is this formula only for if the parabola's positive?
Yeah, I could put a negative. Tomorrow, we're going to take all of them and combine them all. We're going to do it all. A, H's, and K's. This is just for H. Yeah. Oh, on Monday. Yeah. Now, is the shape of the parabola changing? Thumbs up, thumbs down. Everyone. Is the shape changing? No. Is the axis of symmetry changing? Yeah, because now we're moving side to side. Is the vertex changing? Yeah. Let's see. So when our parabola is y equals x squared, my vertex is 0, 0. When my parabola is y equals x minus 3, I'm like, you're not going to fool me. I know the h is positive. Is it the x or the y that changes? I'm moving side to side. Yeah, so it's the x that changes now. And when my parabola says x plus 4, what is my h value, folks? Don't be tricked. Negative 4. Good. So, yes, the vertex changes and the axis of symmetry changes. So when I have my parent parabola, my axis of symmetry is x equals 0. Can you fill in these other axes of symmetries? Well, it moved 3 to the side and negative 4. So what I notice is that the axis of symmetry is whatever your h value is. Your vertex is whatever it's h comma 0. Almost. Finish up writing this, folks. If h is greater than 0, then it's going to look like this. X, for example, plus 3. Oh, sorry, other way around. If h is greater than 0, it's going to say x minus 3. And we move right. If h is less than 0, it's going to fool us, and it's going to look like it's positive, but we're not going to be fooled, and we're going to move. We're going to translate left. Folks, I think you did some good work today. I don't know if your brains are hurting, but I'm really making you think throughout the lesson, and I feel proud of you. Like I can feel the math energy. It's wonderful. So you know your homework. And what I would suggest is go ahead and review yesterday's lesson as well over the weekend as a way of preparing yourself for the quiz next week. Okay? And have a wonderful weekend.